Now see your electric field. What is electric field? Suppose you have got here the charge q, this is capital Q. So, this charge q is placed in as at any point in the space. So, the region around this charge where its force of attraction or repulsion can be experienced by another charge is known as electric field of this charge. So, this charge is considered a source charge. So, it means the space around this charge is where its influence can be experienced is known as electric field. Now, suppose at a distance r there is a charge q naught is placed. This charge is q naught. This is known as test charge also, its magnitude is very small. So, the force experienced by this q naught is to this side, it is F is equal to 1 upon 4 pi epsilon naught q into q naught upon r square, and here we can write r cap here, r cap direction is to this side. Now, this is the force experienced by test charge. So, electric field intensity at this point at a distance r, it means is defined as E here at a distance r is equal to F divided by q naught, and here we write limit delta this q naught tends to 0. Limit q naught tends to 0 means the magnitude of q naught is very small. It is taken in such a way that it does not affect the electric field of the source charge. Now, so we can write E is equal to q into q naught divided by 4 pi epsilon naught r square q naught r cap. This will get cancelled. So, we will be getting q upon 4 pi epsilon naught r square r cap. So, this is equal to the force experienced by unit charge placed at this point. Thus, electric field intensity at a point is defined as the electrostatic force experienced by unit charge placed at that point. So, now this is about electric field intensity. So, direction of electric field intensity is in the direction of electrostatic force. If it is a suppose positive charge, unit positive charge, so the force experienced by this is outward, and if it is the negative charge, then the force experienced by this charge is inward. If the source is here, suppose source 1 is positive charge, source charge is positive, then the direction of electric field is radially outward, and if the source charge is negative, then the direction of electric field is radially inward. We can depict this one with the help of diagram. So, if there is a positive charge q here, so the direction of electric field is here radially outward. If it is here negative q, so the direction of electric field is radially inward. Now, if you have taken plus q here and it has got electric field intensity at any point r here, if I am placing charge q, which is not unit positive charge, electric field intensity at this point is E, then the force experienced by this charge can be written F is equal to QE. So, we can also write here the unit of electric field intensity E is equal to F upon Q, that is here Newton per Coulomb. So, this is the unit of electric field intensity. Now, so we can calculate electric field intensity at a point due to large number of the charges present in that system. So, that is according to principle of superposition actually. There are the charges q1, q2, q3 here, and we are going to calculate electric field intensity at point P. So, we assume at point P there is unit positive charge. So, because of q1 electric field intensity is E1, and because of q2 electric field intensity is E2, and because of q3 electric field intensity is E3. So, we can write total electric field intensity E is equal to E1 plus E2 plus E3. If there are n number of charges, we can write E is equal to E1 plus E2 plus En. And now we can also write here this E is equal to Q1 upon 4 pi epsilon naught R1p square R1p unit vector. or 1p means that is direction from here q1 to p this side. Similarly, here we can write for the next one, and for the last one we can write here q n upon 4 pi epsilon naught r here np and r np unit vector. So, this is due to the nth charge. So, now we can write the total electric field intensity is this. We can also write in the another form, that is in the short form. We can write E is equal to here 1 upon 4 pi epsilon naught sigma I is equal to 1 to n q I divided by r I is equal to 1 to n. Here we can write r I p square and r I p unit vector. So, now see here we have done the electric field intensity here due to the system of the charges, but see here the electric field intensity does not depend on the magnitude of the charge, that is q naught we take at that point where we calculate electric field intensity. It is independent of the q naught. Now, see here electric field lines. What do you mean by actually electric field lines? So, let us see its definition. An electric field line is a curve drawn in such a way that the tangent at each point on the curve gives the direction of electric field at that point. So, if you have taken a curve like this, so the at any point tangent at any point gives the direction of electric field. So, see here electric field lines we can draw by taking a unit positive charge in the electric field. Suppose a unit positive charge free to move in the electric field. So, whatever is the path followed by the unit positive charge, that is actually the path is known as electric field line. Suppose you have taken here positive charge q. If you are taking unit positive charge around it, anywhere you place, it will move radially outward. So, the path of electric field lines are here like this radially outward. So, the electric field lines for the positive charge are drawn here, or you can see here for the q is greater than 0. So, electric field lines are radially outward. If you are taking negative charge like this, then the unit positive charge if you place in its electrostatic field, it will move here inward. So, we can draw electric field lines here radially inward. Here we can take here q is less than 0.